In part 1, we saw how to use logical tests to see if a point was inside of a box or a circle. Now, let's see how to use and or to do something that would otherwise be very hard. Let's write a very simple game. Here's the graphics window. We have a circle that's controlled by the mouse, and we can go anywhere we want inside the graphics window. Also inside the window is a field. This is just a yellow rectangle. As long as our mouse is on the field, it's in the yellow rectangle, we get points, maybe a few points every second. If we ever want to take a break, we just move the mouse off the field into the gray zone, and we stop accumulating points. Now, this is a pretty easy game, so let's make it a little bit harder. We'll introduce a penalty box that moves around. So now we have to try to move the mouse to avoid the penalty box. To make it even more interesting, let's have a safe box, which gives us extra points. So if the mouse ever wanders into the penalty box, we start losing points really fast. If we ever move into the green safe box, we start accumulating tons of extra points. The way I want to think about scoring this is I'm going to have a separate routine for each of these 4 cases. So one of the 4 cases handles the field, and it says when the mouse is on the field, then I am responsible for adding points. So how does it know if the mouse is on the field? It calls a routine called mouse on field, and the mouse on field returns a Boolean. Here's a little picture of the Booleans that are returned by mouse on field. It's true wherever the little picture is green, and red everywhere the little picture is false. So if we are outside of the field, it's false. If we're in the safe box or we're in the penalty box, it's false. Otherwise, it's true. All of these boxes can be moving, so this is something that the little function has to compute for every frame. What is the expression? How do we combine our tests so that we get true where anytime the mouse is in this green zone, but false anytime the mouse is not? That's the challenge, and we'll see there's no one way of doing it. In fact, there are lots of ways of doing it. The beauty of this approach is that you can do all of this in terms of pictures. You draw little pictures with red zones and green zones, and then you combine them to get the picture you want. If you're a visual thinker, then this kind of thing is a game that you are going to enjoy. Let's take a look at a couple of ways to combine pictures to get a new picture. Here's our starting situation, and I'm going to create 3 Boolean variables: on field, in safe, and in penalty. And these are the result of calling point in box. On field is calling point in box with the field, in safe is calling point in box on the safe box, and in penalty is calling point in box on the penalty box. So if I draw a little picture for what each of these 3 things returns, this little picture for on field says anytime we're inside the field box, anytime we're inside the yellow box, it's true. Otherwise, it's false. So this little picture shows us the results of on field point for point everywhere in the graphics window for a given frame. Remember, all these boxes can be moving, so we're going to freeze this at one moment in time. In safe is true anytime we're inside the safe box, otherwise it's false. In penalty is true anytime we're inside the penalty box, and otherwise it's false. So now the trick is to combine these 3 things to get something that's true when we're on the field, but false if we're in either box or off the field. So there are lots of ways of going about this. Let's try one of them. I'm going to say that I want my result to be true if I'm inside of field, but I'm not inside of safe and I'm not inside of penalty. So how do I tell if I'm not in the safe box? Well, I take in safe and its picture and I compute its opposite, not in safe. And it would be this picture. This is the reverse of in safe. Everywhere in safe is true, not in safe is false, and vice versa. I'll do the same thing for in penalty. I'll take that picture and I'll create not in penalty. Now it's true everywhere that in penalty was false and vice versa. Now I can take these 2 pictures and combine them. One way to think about it is to use an and, where I will and these two pictures together. The result is that it's green only where both are green. That tells me I'm not in either box. Let me show you what I mean. If I take the picture on the left and the picture on the right, and I combine them with this expression, I just and them together, then every point in the new picture is green if both of them are green at that point. Otherwise, it's red. The result is anything that's red in either picture is red in the result. Let's think about this linguistically. Not in safe and not in penalty. Well, we're not in the safe box and we're not in the penalty box. Well, sure enough, that's true everywhere that we're not in the safe box and we're not in the penalty box. We're almost there because these are the regions we want to avoid. Turn your attention now back to the upper left to on field. Notice that this is true everywhere on the field, but it's also true inside of the two safe box and penalty boxes because all we did was test if we're inside the field. So we want to get rid of the safe box and the penalty box. We can do that by combining on field with the result we just computed, again using an and. The picture that results is this. Think about the expression. This is true anytime we are on the field and we're not in the safe box and we're not in the penalty box. Well, that's exactly what we're after, and that's our result. And that's correct. There are lots of ways to get to this answer. Let's try a different one. Sort of the same, but a little bit different. I'll start with the same three variables and the same three pictures. Are we on the field? Are we in the safe box? Are we in the penalty box? This time, I'll ask, am I in the safe box or in the penalty box? So I'll take in safe and in penalty, and I'll or them. Now I'm true anytime either of them is true. So this picture says if you're inside the safe box or you're inside the penalty box, then this result is true. Now I'm going to turn this on its head by negating the whole thing. I'll put the not operator at the beginning, the bang, but I'll remember to put this whole expression in parentheses because I want the whole thing to be inverted. So everywhere that this expression was true, now it becomes false. Anytime it was false, it was true. Well, we can also think of that in terms of red and greens. So this tells us it is true that you are not in the safe box or the penalty box as long as you're not in either of those boxes. And just like before now, we'll combine this with on field by anding them together. So the result is true when we're on the field and we're not in either the safe box or the penalty box. So this is a different result, and it's just as valid. We can look at them all side by side. This is where we began with. This is where we were trying to go, and we can get there this way. This was our first result. Or we can get there this way, which is our second result. And there are other ways of doing it. The point of using these logical operators is not to find the right answer. It's to find an answer that makes sense to you. So you can look at one of these expressions and figure it out. Notice that we have a lot of things going on. We have ands and nots and ors and parentheses, and it can get confusing if you let this get too complicated. So I typically keep it to 3 variables, maybe 4, and I break them up into little pieces. And I almost always draw the pictures because the pictures help me understand what's happening graphically. This is tricky stuff until you get a handle for it. If this doesn't all make sense to you, do not worry about it at all. Like I said, you have to try this out for yourself a few times and kind of work it through for the way you think, and then the pieces will fall together. So I suggest that you fool around with this, write a few little test programs, and try to get a feeling for these ands and ors and nots and combining them. Try making little pictures like these and try making some little games with boxes inside of other boxes, or circles, because now we know how to find a point inside of a circle, and try to make combinations that make sense to you. Maybe you'll color them differently or somehow graphically indicate what's going on. Experiment with this, because once you get the hang of it, you'll find it's straightforward. It never really becomes trivial. I think that there are very few people who can look at either one of these lines and just go, bang, I know what that means. You almost always have to get a pencil and kind of draw a little picture or make a little diagram and pull it apart into its pieces, and then you know what it is. And that's one reason why comments are so useful. And if you're very lucky, they use nice names like in safe or in penalty, and that helps you pull this apart. So it is a dense little bit of programming, but this is the way we do it. We build up these logical constructions by combining the pieces. Just don't let them get too hairy. Keep them under control, don't make them too complicated, and you'll be fine. And you'll love the power of writing a program that can respond to a whole variety of different conditions.